What's up? What's up? Let's do some codes. Oh, let me do my green screen effect so that y'all can find my YouTube. Man, I always forget that until like I'm already streaming. It's like so unprofessional. Whatever. I'm not a professional. I'm not a professional streamer at this point. Maybe one day. I don't even know if I ever care about being a professional streamer. Like that's not really even a goal of mine. All right, cool. So I think um, TikTok should be able to see full screen youtube.com/C John Vanderveer. Um, cool. So let's do some codes. Let's do a quick merge sort. We already did merge sort. We already did merge sort as a component of the previous problem, which was merge k sorted lists. So we already did it. So let's just get credit for it. It's right here. This is the merge sort. So I could just copy that, but I'm going to try and remember it. Cool. And so the inject list node was one of those big weird things, right? And the edge case around if list 1 and 2 are both empty, then we want to return null. Even though the output says like that it's an empty array, they actually want to return null. So we'll do, I guess, an edge case checking for if they're both. I don't need to check if they're both empty. I just need to check if we're gonna have a result which is a new list node, and it's gonna take negative infinity, so that any number will be greater than it. That's the idea. I think they said you can assume like positive integers, but my implementation will support it even if they're not. So if I have result and then if I'm picking, but let's say that there's nowhere to pick, it's only negative infinity. In that case, yeah, basically I can check if the top node is negative infinity. And if it is, then return null. So result.val I guess that. It's not, yeah, it may be more readable to explicitly check list 1 and 2 are null. Oh, there's like some glare on the screen. Sorry about that, y'all. YouTube is going to have a better view. That's one thing that I can say for sure. All right, so that handles the edge case. It's not like the most elegant handling, but it handles it. So what we want to do is while, we're going to just pick from left, pick from right, whichever is smaller, because we want it to go ascending, so small to high. So while list 1 and list 2, then we handle one list is shorter than the other. Okay, so while list 1 and list 2, if list 1 dot val, we're using val, right? Yep. If it's greater than or equal to list 2, no, hold on. If it's less than or equal to, we want it to be smaller. And then in equals case, it doesn't matter. List 2 dot val. So we have we'll call this result head and builder pointer. Result head and builder pointer. And builder pointer starts by pointing at result head. And I actually don't think I need that special handling down there because I can return result head.next, which is going to be null by default. I might need to explicitly set result head.next to null by default. No, I don't think so, because when I construct it, I'm looking at the function definition for list node right now. When I construct it, if I don't pass next, it's implicitly undefined, and then it explicitly sets null, which is what I want. So if list val is less than or equal to the value for 2, so I'm just comparing the head nodes from each list, right? So if the first one is smaller, we're going to point the builder pointer to that. Builder pointer dot next is list 1. And then let's increment list 1. You see how we kind of move list 1. So list 1 is moving itself. And then we'll do an else condition and do list 2 there. And then the builder pointer needs to pointer needs to increase over here. The builder pointer equals builder pointer dot next. So there's like 3 different concerns in scope here. So this would be list 2, and then let's bump list 2. Okay. Now the while loop is broken because we've gotten to the end of one or both. We're actually not sure. I take it back. We're sure. We have gotten to the end of one of the lists, but not both. So we want to append the remaining list's tail. So we can just check which one is it. If list 1 still exists, then that one has the tail. Builder pointer dot next equals list 1. Else builder pointer dot next equals list 2. This is my first shot. I think this is basically correct. So builder pointer, is it because I said const? Yeah, so, yeah, I need to do so we will reassign the builder pointer reference. Okay, it was accepted, cool. Let's see if it passes the other test cases. Yeah, it did. Cool. Looks like I wasn't faster than, like it was in kind of almost the bottom third, but not quite in terms of speed. So maybe there is a, let's look at the solution. There could be a faster way. Recursion, I didn't use recursion. Iteration, yes I did. That's it. There's either recursion or iteration. So I guess this is a case where like the time complexity analysis for recursion and iteration are equivalent, but in practice, given various test cases that are used, recursion is faster. Or it could be that, yeah, it could be that they're asymptotically equivalent, but that like recursion is twice as fast. But asymptotically that disappears, right, in time complexity analysis. So that would explain why the time complexity is kind of on the slow side, not like way on the slow side, but a little bit on the slow side. What is a little baffling is why is the space complexity? Okay, I guess maybe I don't need to declare result head. I could do this. Yeah, I could do this using either list 1 or list 2 instead of creating a new one. I really just created a new node. I didn't actually create a new list. I just created a new node, which is only constant difference there. Anyway, I'm happy with it. I think this works. I'm not really sure why Oh, and the other thing is like, right, I always forget about this. Leetcode submission performance varies like pretty wildly for JavaScript. So we can just run it like 3 more times and see, yeah. I went from the bottom third to the top 20% just by rerunning the code. Ooh. Can't you stream your screen directly? Maybe. I'm not smart enough to. I don't know. I'll tell you, I do know how to stream my computer screen to TikTok. I do know how to do that. What I don't know how to do is to stream my screen to TikTok and all the other platforms concurrently. That's something I think I need help with. So instead, what I do is I stream to all the other platforms, and then I point my phone at my screen for TikTok, which is totally janky, but it kind of works. Yeah, I would love it if I could just stream to all the places, but I don't know how to do that. All right, so we got this problem done. I want to do binary here. So this works, but it would be faster. Oh, look, my runtime went up. Even though the code didn't change, it went 300, 350, over 400. So exciting. It's almost like going to a casino, you know? You run the same code, you have no idea how well it's going to do. It's wild. So what I'd like to do is implement binary interval merge right here. So while lists.length is greater than 1, I need to pair them off. How can I pair them off? Yep, I'm happy to just look at the solution because I'm just trying to sort of drill these things. So this is how they do it. Amount, len, list, interval, while interval is less than amount. And set the interval to be 1. Let's do it. Interval equals 1. Let's actually merge k lists linear. And so I'll actually keep both here. Merge k list linear, merge k lists. Binary interval merge. Okay. So here's the interval, and while list.length is greater than interval, and then at the bottom of this, we can do interval double the interval. And this is how we're going to get our super speed. It's like exponentially faster. Why can I do that though? Why can I do that? I need an inner loop. Okay, that's what I'm missing. Yep, so I actually need an inner loop here. So this is going to be for let I equal, do I already have an I? Am I polluting I's? I is less than list.length I plus plus. Do I want to go into list.length or do I want to go into the interval? Hey John, what's up? PhD from where? George Mason University. So, I'm not sure that my iterator loop is correct. So the Python solution says for I in range 0, amount minus interval, interval times 2. Is it worth getting an econ PhD? Not for the average person. Only for a specific, only for a person that is in a like specific kind of situation. Is it a good idea? Map for complete beginner. Here you go. 5 to 23 patterns to ace any coding interview on Hacker Noon. Now this is a map for a complete beginner on algorithm problems. But if you're a complete beginner on programming, you should not even start algorithm problems yet. You should go to Codecademy and look at the front end engineer career path. So if you don't even code, but you would like to start coding, strongly recommend this guy. And it does cost money, so if you want something free, go to Free Code Camp. But if you have money, this is substantially better. Okay. Yeah, that's for web application. Yep, Austin, this is for web applications. Okay, cool. I guess I'll sort of just like write out the loop logic that I see, but it doesn't super make sense to me. I think that got me in trouble last stream, didn't it? Interval, amount minus interval. List dot length minus interval. Interval times 2. I don't know if that's going to work at all. Yeah, it doesn't work at all. Assignment to a constant variable. Wrong answer. Output was 113445. 113445. So we skipped to 6. Let's do it this way. I used PyCharm IED. That's fine. HTML JVS. I don't know what you mean by JVS. CSS. I think you just mean JavaScript. CSS, Python, backend with Django. You could do that. I think Django is sort of a weak server, but if you already know how to do Python, go for it. Okay, I'm going to focus on getting this problem working. So something doesn't work here. Yeah, no, let's look up a JavaScript solution. I just want to build a web application. Yep, I hear you. This is merge k-lists. Okay, cool. Root, so this is a recursive approach. Well, recursion is definitely intuitive. It's definitely intuitive, but it's not what I want. Nope, that's not what I want. This is just an integer iterated for loop. This is not what I want. Context. We're practicing Leetcode, that's all. Trying to do the binary divide and conquer, basically. Reverse binary merge, divide and conquer. Let me look up the Python range definition. So this is creating a range from 0 to amount minus interval. And the third parameter is the step, I believe. So range 6. For in range, let's say 0 to 10. It would be 0, 10, not 0 to 10. Yep. So it's 0 to 10. Now what if I do 0 to 10? What is this? This is like a step parameter. Interval times 2. What do I just make it 2? Now it's even numbers or odd numbers, one of the two. Do you think WordPress with custom code can build a complex web app like Fiverr? It can, but it's often going to be very slow. I've actually done this early on in my career a number of times. Yeah, so that's how I get even numbers. Right. So this is a really slick, cool way. 3 or 5 ways Python is a DSNA cheat code. 3. Range method. So what is the JavaScript way of doing this? I need to grab I every interval instead of I++, I want to say I plus equals interval. Cool. Got him. It's not that bad if you can actually understand what's going on, right? Geez, easier said than done. Think we got a winner, folks. I think we have a binary interval merge. Ha, look how slow that was. It went over 600. Yeah, this needs to be faster. Why is it so slow? I want to see it get under 280. Over 700. Golly. You know what? I'm going to, let's see. Why is it so slow? Can I do this without splicing? Let's try and do this without splicing. So let me comment that, and I'll do lists of I. Yeah, I think this is the problem. List of I and list of I plus 1. Oh, no, list of 0 shouldn't be result. What should be the result? List of I should be the result. All All right, let's copy that and undo what I've done. So here, instead of list 0, we'll do list of I. List of I. I plus 1. Now it's splicing out of bounds, I think. So let me change from splice to slice. Look at this Python solution. They simply reassign lists of I to be the merge of, oh, plus interval, not plus I, plus interval. This works, but instead of lists, I would like to use I. And now it doesn't work. I'll give this 3 more minutes and then I'll punt on it. We're still quite slow, so I think this is implemented incorrectly. So they are doing this without splicing. Let me go back to splicing, but let me try and parameterize the inputs. So splice from I plus interval, and then we are going to splice 1. Oh, can I just do that? No, I can't just do that. Oh, that needs to be I, first of all. Hello. I is less than list.length. Yeah, that's definitely wrong. While list.length is greater than interval. Interval is 1, so while list.length is greater than 1. So let me try going back. This should just be the original implementation, basically. I is not defined. Okay. How is this not equivalent to the original implementation? Let me do result. So while list.length is greater than 1, while list.length is greater than interval, interval is 1. To merge is splice 1, 1. To merge is splice 1, 1. Result is merge two sorted lists. Yeah, it looks like the original implementation to me. I'm missing something here. All right, so that's accepted. Because interval is growing. That's the difference. So if interval is not growing, yep, now it's equivalent. All right, so let's do here well, let's just do, can I just do that? No, okay, I can't do that. Can I do slice? And then it never terminates. Ew, gross. So what if we iterate straight through? And now I do I plus 1. And that is I, line 111. So that's a wrong answer. Cool. All right, so this is not efficient, but this is going to get us better set to do the reverse binary merge. So now I am stepping through with a tracking integer, which I need for my binary search interval computation. So that's a step in the right direction. So I'm still splicing it this time. Is that okay? I'm worried that splicing will throw off my index, basically. So if I'm doubling the interval every time, yeah, I might get the wrong answer, but I should never infinitely loop. So here, now that I'll never infinitely loop, let me try. Oh, before I go that direction, maybe I can do the list I plus 1. Nope, dang, that's going to loop. All right, I will try to do the binary thing with splicing. So this should work, right? Wrong answer. What is going on? Yeah, I guess that's even faster. And not sure why I had to change that. Well, it's logging as much faster now. But it's still not binary. So let's try switching my loop. All right, yeah, I think I'm gonna have to pick this up later. I'm surprised, like even looking at the solution, it's still not straightforward because of the range operator. So what the range operator is doing, it's saying from 0 until amount minus interval. Until amount minus interval. So what I can do is until amount minus interval what? Until I equals amount minus interval, I think. So here, no, it's a less than comparison because it doesn't show 10. So I is less than amount minus interval, and this would be list.length. And I plus equals interval, no. The interval times equals 2. I'm going to do 2 options. And I times equals interval, or interval times equals 2. I'm actually not sure about which of these, so let's try each of them. Boop. Hey, that was accepted. Wow. So that was accepted, but the runtime's really slow. What if I switch it to the other one? Wrong. So it looks like this top one. So that was accepted. What if I just do one of these? So I'm not using the intermediate variable. It's also accepted. Cool. What I'd like to be able to do is to slice instead of splicing, but maybe I just can't do that. It's the wrong answer. All right, y'all. Well, I got to go. Thanks for tuning in. I guess we're going to have to do a part 3. So follow the page, subscribe to the YouTube channel, etc., etc. And we'll do a part 3 where we finally get to the alien dictionary problem. We still haven't even started it.